All right, so I thought I would show an example of making a small application in Haskell to sort of show that, one, it's not so different from other languages, really, when you're trying to solve these small issues. It really kind of gets different when you have larger architectures and you have to make those decisions. So what we're going to be making is just a small tool for seeing which directories or which subdirectories recursively in a given directory are Git repositories and have unstaged changes. Meaning, if I run it on my entire code folder, I should get a listing of all of the directories that have changes, but they are unstaged. The reason for this is, well, I've made this application before a long time ago, because I had so many folders and so many projects that I sort of was working on for quite some time. And then you make a change, you kind of, maybe you're away from the thing for a couple of weeks, you don't remember that you made this change. You're not reminded at any point in time. So I think it could be useful to make an application that does this. It essentially informs you, hey, you have these subdirectories that have unstaged changes. So let's get going. I'm running stack new here with the name unstaged. That's going to be our application name. And then we have the template control basic. We're going to go through the, I guess by now, very normal flow of doing this. We're going to reopen this in a container because I like the environment that we have. And so we're going to be trying to do this sort of with the REPL initially. I've changed the, let's see if I can show this actually. So in library here, I've changed the function name here to run main, because this is a little bit better when you're working with the REPL and you're running your main function, for example. It doesn't get confused anymore. This is not really a big change. The corresponding change is made here as well in the main. So that's all fine. This shouldn't really be an issue. What we're going to do in this application immediately is we're going to pull in a dependency called Rio. Rio is essentially a standard library. It's called a prelude. The prelude is the code that sort of you're expected to import in most places, let's say, right? These are the tools you have at hand already by default, right? So some languages call this core, some languages call it kernel, and so on. This is stuff that you, generally speaking, have available to you at all times. So we're adding Rio here, and we're gonna do, let's actually do stack REPL. It will load Rio. It will build Rio now. We don't have this by default in the basic image. In the application image, we have Rio by default because we construct Rio applications in that template. In the basic one, we don't have this by default, so we instead go here, right? So now if I run main, this works, where previously it didn't work as well because library also had the function main. Now it has run main, so the REPL doesn't get confused. Very small change, doesn't really matter. What we're going to do here, because we have Rio now, is we're going to say import Rio. And what's going to happen here in this example here is actually that we no longer have access to put Sterling. So I'm going to just say import system.io put Sterling. Of course, you don't have to do this. There's nothing that says you have to, you know, use put Sterling or whatever, but it's fairly simple. We're making a small application. We really just want to print some stuff to the screen. So with that in mind, let's sort of break down the problem, and let's start at an end that might be a little bit unfamiliar to a lot of people. Let's just start with some types. let's think about like what does it mean to have a Git status in a way. We know we want unstaged changes. That's a status, right? We don't really want to call that like a Boolean where it's unstaged or it's not, because the truth is a directory can be in some different states, right? So we want to sort of think about this a little bit. So let's say data git status. What is a git status? Well, we know unstaged changes, right? Um, that's one. So what about another? We could have a directory that it's not a Git repository, right? Uh, we could have a clean Git repository, right? And we could have a no commits directory, right? Like if we, for example, checked in this directory, we would see git status. We have no commits yet, right? That's a git status. So we probably want to handle that as well. So with this in mind, let's start here with this here, right? And let's say deriving EQ and show. For those wondering, deriving says automatically generate this capability for this type. And EQ here, EQ, is equality. So that means we can compare two of these. Show is so we can show it in the terminal. So with this in mind, we should have git statuses. So unstaged changes is a git status, right? This all works. Let's try to consider what do we do in order to get the git status of a directory, right? Of course, there might be a smart way we can use the files inside of the Git directory, but when we're solving a small problem like this, and we're not kind of looking forward into the future, we might do shell execution, right? This is not completely unreasonable. And I'm not saying raw shell execution and so on necessarily, but process interaction from our programming language. And with that in mind, let's add a package called, I think it's typed process. I might be wrong about this. Let's see, stack REPL. Was that included by default maybe? Import system process. Right, so it's here. Let's import this qualified. We're importing this as process now. Now we get a warning that says, yeah, you're not using it. So what we're interested in getting the Git status output, right? And we might want the standard error output as well. So let's try to take that into account. With that in mind, I'm going to say process output has one constructor with two fields. Standard output, which is, well, let's create a new type for this. This might not make sense for this small example, but you kind of never know with these things. So output string, output bytes, let's say error output, error bytes. And I'm going to define these new types. First, we're also going to say deriving EQ show. This might seem tedious. It's less tedious than defining these on your own. So new types are effectively wrappers around some other type. They don't actually appear at runtime. They essentially create a way for us to know that, hang on, this one is a special type of, for example, string or whatever. And it's useful when you have an API that says, oh, I take 3 strings as arguments. Well, any string? No. You might label them in a way with these new types that say, no, these are not just any bytes, they're output bytes. These are not just any bytes, they're error bytes, right? So with that in mind, let's say output bytes equals output bytes. And this is just saying that the type is called this and the constructor is called this. You could name them differently. I really don't kind of recommend it. It's useless to do that, to be honest, usually. So we're just going to say that these take byte strings. And a byte string is, well, it's exactly what it sounds. It's a string of bytes, meaning it's the closest you can get to sort of this idea of ASCII strings in C or whatever. And with this, we're going to be importing Rio byte string. Again, Rio is essentially a standard library. By the way, you can see here that we have several modules for this, and we're actually going to be using the lazy one here. So with this in mind, I'm going to import the type byte string, but I'm also going to say import qualified Rio byte string as byte string. Lots of people import this as BS. I kind of don't see the point, if I'm being honest. Let's see, byte string lazy is the correct module. We're going to import that as lazy byte string. I'm not going to import the byte string type from lazy byte string. We're going to leave that one as it is. We're going to get more we're going to get more warnings that we're not using stuff here, and this will all sort of work out. I'm actually going to move this down like this. I think it's nicer that way. Doesn't really matter, of course. So how do we run a process and get stuff out? Well, let's create a function called getProcessOutput. So it will take, yeah, let's take a string. This is the command we want to execute. This will become clear why. We're going to return one of our process outputs like this, getProcessOutput, and our command string is basically anything. I'm going to use do notation here. Honestly, it's just good to kind of do by default in most cases. So we want to take our command string and turn it into command plus arguments. So with that in mind, let's do case words on command string. Words here is a function you can see here in the example. It takes this lorem ipsum string and splits it into the separate words. That's basically it, right? It's very useful for situations like this. If it gets an empty string, it returns an empty list, by the way. So we're going to case on that, which means we're going to inspect the result, right? And I'm going to say here that, of course, we can receive an empty list. And I'm going to call that for now, because this is a small application. We're just trying to solve a small problem, right? Empty command string. That's all. We're going to throw an error there. And for those of you who didn't know, Haskell has exceptions. People are surprised by this. I guess it's a fair assumption. Why would it have that, right? Because people really insist that Haskell is this sort of cathedral of, oh, we do everything properly, and you know, these are dirty things you shouldn't use. Exceptions are very common in Haskell. So, however, in the other case, if we don't have this error that we have an empty command string, right? We want to take the first argument, that is the command. The rest is the arguments to that command. The rest are the arguments to that command. Here we're going to do stuff. Now we have the command, we have the arguments. And I'm going to say, because this system process typed library requires you to create a command config configuration for running your command. It's a bit more advanced than system.process itself, but it's also, honestly, easier to use, provided you have some foreknowledge about some things. We're not going to go too deep into using this library. I'm writing this function here to illustrate to you that this is what the function does, what we're trying to accomplish, right? So we're going to start with this process configuration, right? Did I call it command configuration? Anyway, doesn't matter. We are trying to create running a process, right? So we're going to create this config. What I'm going to do here is, some of you will know this. Actually, I'm going to illustrate sort of the other thing first. Let's say we're running our command. We're running it with arguments. This is how you create a process config by default. And you'll note here that here we have these arguments here. Why would you have 3 unit arguments? Well, it turns out that these are actually generic arguments, so they're type variables. If we pass different things to this process config, we're going to get different values there. And I'm going to show one instance of this first, and then we're going to kind of generalize from there. So we can set our standard out, for example, right? So process set std out, this function here, right? And we're going to set that to byte string output. This one. And when I call this like this, right, we can see we're applying this function, right? This is being applied to that other thing, right? We have parentheses here. So what we can do is we can just say $, because that applies the thing on the left to the thing on the right. However, I would like to propose that there's a different, better, or more intuitive way of doing this, to be honest, that is criminally underused. So what we're going to use is the AND operator. I don't know if they call it that, but you'll see why I call it the AND operator. So we're going to take this here. We're going to move that up to there. And then we're going to say and this is the same thing. So what this does is it takes whatever value you have here and passes it to the function that comes next, with the value being passed in as the last argument. That's why this works. So with this in mind, we can add more, right? So now we're going to set std right? Byte string output, right? And so now we have our config. We construct the base of it here, and then we're setting the standard out here, and we're setting the standard in, or here, right? So standard error is also going to be byte string output. And yeah, that should be it for the process configuration. Now we're going to run this. This gets a little bit involved, but I'm going to try to explain sort of the different things here, what's actually going on. So we're going to call a function called with process wait. We're going to call that with our process configuration. This will actually, if I say x here, we're gonna see now this hole here is actually a function, right? It stands in for a function. It takes a process with nothing as input and a lazy byte string as standard out, and a lazy byte string standard error. It has wrapped these in STM, and what you need to know about STM for this tutorial is essentially it's a context where we can execute things transactionally. The reason that this is used in this library is because these can now be essentially interacted with from many threads and so on. So this is a little bit of an implementation detail, but we're going to deal with this. It's fine, right? So I don't want to make this a bigger deal than it actually is. So with that in mind, importantly, we're going to take this process configuration here. We have to produce an I/O of process output, right? Because that's our return result here. So we're going to say we have our process here, right? And if I did this now, we would essentially get, okay, so we have to produce I/O of process output. So how do we do this? Well, let's start off strong with a, actually let's say STM atomically. Of course, we don't have STM imported yet. Oh, hang on. Okay, that's good. So now it's telling us we have to produce an STM of process output. That's because we're running this atomically function here that says, I want to run a transactional function. And I want to produce a value from that, and we're going to turn that into I/O, because that's what our return result is here. So what a transactional context is essentially it has reduced effects. It has reduced effects because we want to be able to retry this function if it fails, as transactions are, for example, in databases. So let's not go too deep into STM. It's not really super relevant to the end or to the rest of this, right? So what we're going to get here, though, is we have access to these variables, right? So let's say that we have our out bytes, right? That's our standard out bytes. We're going to get and this we're going to replicate for error bytes. Get standard error. First of all, is this valid? Okay, yes, that seems valid. We still have to produce process output. So let's look at what our process output contains. Just as a note here, pure is a way to wrap a value in the context you're currently in for this particular example. It's a bit deeper than that, but let's leave it there for now. So we're wrapping whatever value we are trying to produce in STM in this case, right? And we're going to see that in the type signature later. So here we have standard output. We have standard error. Let's see if I standard output. Oh, hang on. Let's see if we can. Yeah, let's say standard out, standard error. Yeah, this will be better. If we do this, we will see that we don't have these bound. So we're going to have to figure out a way to construct these values. What do we actually have here? Let's say we have standard out. We want to construct we have some values here. Let's see if we our error bytes are lazy byte string, right? Our out bytes is also a lazy byte string. So let's take that and say we're going to convert it into a strict byte string, right? And output bytes is also a new type, and I'm going to show you here how to use that then. So first we're going to say lazy byte string dot toStrict is a function that does this. And I'm going to pass standard out or out bytes rather into this precisely as we did before. The reason being I have a third step here or a second step where we're going to wrap it in our output bytes constructor, right? So now if I save this, we should be saying, okay, this is no longer complaining because this value actually makes sense. So here we're going to say error bytes, lazy byte string dot toStrict, and then error bytes, right? And now we have these values available here, right? We have now created this from our from the standard out and standard error interaction here. So this runs the actual process we sort of have specified, right? And what we're doing here is we're constructing our own structure from this, right? We get lazy byte strings and we turn them into strict byte strings and also pack them in our own constructors for these byte strings so we can tell at the type level the difference between one byte string and another byte string. So output bytes and error bytes, right? And then we say pack this up in the STM monad here. Again, I said we will look at this, and you can see here, pure here in this context is typed as taking a process output and packing it essentially in this STM monad, right? So pure is just a way of saying for whatever context you need at this point in time, at this juncture, wrap whatever I'm passing you in that context, right? So if we have a function that expects a maybe, pure will wrap it up in a just constructor and so on, right? It's not really magic. It's not super advanced. It's just a function that wraps a value, right? So with this in mind, let's maybe take a look at sort of running this. So get process output with LSA should probably give us something, right? And indeed it does, right? Here we can see the standard out is output bytes with this string here, printing on by default in the development container, and we receive nothing on standard error, right? So now we have sort of a way to run a command, right? The interesting thing here, though, might be typed process has a way of setting your working directory. So we might want to take that in as an argument as well. So working directory is a string. And here we see this kind of issue again, right? I take two strings. Well, okay. How are we going to sort of make a difference between these? The API really doesn't make a reasonable difference, right? For example, if I pass the working directory here, this doesn't work, right? And this is a silly API to have in a way, right? Of course, this is not always a problem. If you're making a small tool, it's not really an issue. I do think, however, that it's good to make these kinds of new types. So what we're going to do here is we're going to create a working directory type and a command string type. These are just new types. So we're going to take this definition and say working directory string. We're going to call this a file path. It's a common type alias to use for path strings. This one is not a new type. It's important to know. So here we're going to create the command string type. And now we have these two types, right? Importantly though, if I save here, this is going to tell me, hey, you kind of can't unwrap this command string. What are you trying to do exactly? And that's because this is now a distinct type from a string. That's the point, right? So the easiest solution to this is just saying command string here, unpacking it in the function head. And this solves our problem here, right? So we save, and it's no longer a problem. We're going to do the same with working directory, if I can spell. And now we have a better API that doesn't allow this, for example, right? Okay, this doesn't work. So we're going to do working directory /tmp command string. Again, you don't need to do this for everything all the time, but it's a good sort of habit to get into when you see these potential issues. Now we get the same thing. I've now run this command inside of tmp, right? So now we have something that resembles kind of, yeah, this seems to work, right? So what happens if we run git status? Okay, so now we have error bytes here, right? Fatal, not a git repository. Now we know what happens when we run this command in what is not a git repository, right? That's good information. So if I say run this in the current directory, we have no commits yet. Good to know. What happens then if I say, let's see, I'm going to install Magit or Magit, depending on how you want to say it. So we're going to stage everything. And with this, we're going to have seen all of the different steps in this journey, right? Okay, nothing to commit rather, working directory clean. Okay, so that's another case. We have no commits yet, nothing to commit, working directory clean. Let's make a change so we can see unstaged changes, right? Right. It doesn't have to be a reasonable change. It kind of has to be something that doesn't complain. So, or format rather. Changes not staged for commit. Right. Now we have the different sort of situations that we can end up in, right? We have these in the terminal here because we've experimented with the terminal. We run these commands in the terminals. We can see some of this, right? Of course, we might not scroll back necessarily. We might remember parts of this, but it's good to have them there. We've experimented a little bit, right? So with that in mind, now we can sort of create these values here, right? So if I say get git status, right, it takes a file path. And again, this is not a, let's actually say, no, let's call this a file path for now. We could make a new type for this. We might not. It doesn't really matter. So we're going to return a get status. And I'm just going to say IO get status. What this implies, why I'm saying this is because this implies that we cannot fail. Or if we fail, it's an IO exception. This is important to know. If I wanted this to fail kind of safely and quietly and not crash things, I might say maybe here. I might say either that or some string explaining the error or some git error that I've created, for example, right? Well, for now, we're going to say this is a git status. Get status equals, and we're going to say we take a file path, of course. We're going to get our output. So process output, get process output. And we're going to say we are going to work within the directory that we've been given. And we're going to command string git status. And what does this actually do, right? I'm going to just experiment a little bit with this and say we always return clean here, and I want to print process output. We might have to add print here. This is really only for... Actually, I will show you a debugging technique. Trace show. Trace show m, maybe. Right. So it's giving us a warning here. What this is telling us is you have a trace statement left in your code. And that's only for trace show m and trace show and so on. They're supposed to be used in debugging. And that's what I'm doing here, right? So let's reload there and say what happens when I do a get git status on this here. Okay, so I'm getting my output, right? I'm getting the process output here from this. So now we have to essentially ask about this process output, right? Let's create handle process output. No, maybe not actually, because we can sort of start asking questions here immediately. So what I'm going to do here is say case process output of, and we're going to unpack these values. So let's get process output. Well, actually, we could deconstruct it already here. We know that we have a certain structure, right? So standard out is equal to output bytes, out bytes. So we're pulling this out from the structure already, right? And I'm going to new line here. This might look a little bit ugly, but we're gonna live with it. Standard error is equal to error bytes. Error bytes. So now I'm pulling these two values out, right? And what we get here, process with two S's is good to use. And now we can no longer actually show this, right? So that's important to know. If I wanted to have both the binding here and the actual sort of name, I could say process output at. And this would give us both, right? Now I have the value named as process output, but I also have the values inside. And this is useful. However, now we're not going to print the process output anymore. So we are going to ask questions about this actual structure, right? We have the out bytes, we have the error bytes. So with that in mind, there is an extension. First, we could say if out bytes byte string is infix of. No, actually, wrong order. So if the phrase changes not staged for commit, if that phrase exists in the out byte, we want to then we want to return unstaged changes. And let's say that else we want to return clean. So now we're asking one question essentially, right? We're asking simply, does this actually exist there? If it does, return unstaged changes. So with this in mind, if we run this currently on our directory now, we get unstaged changes, right? If we run it on TMP, we get clean. And this is because of the else branch, right? So what we're not going to do here is do if then else, if then else, if then else. This is not, I mean, it's not untenable, but there's a better way, sponsored by language extensions. If I can remember the syntax here, you'll excuse me, I hope. We're going to be making these guard statements here. And then I think it's arrows. We'll see. This is not the end of the world. And this takes an otherwise, I think, pure clean. So this should effectively be saying the same thing. And now it's saying you're using a multi-way if, and that's this here. You're using this even though you could get by with simply an if-else, right? However, we're going to be asking other questions. So we saw in the previous example, if the phrase no commits yet exists, right? We want to return no commits, right? If the phrase, let's see, what more do we have? Not a Git repository, right? If this exists in standard error, right? We want to say, well, this is not a Git repository. Oh, what did I do here? Like this. Not Git repository, right? And what more is there? Let's look at our type. Clean, no commits. So nothing, let's see, what was the clean one again? Nothing to commit, working tree clean. And we're going to run into an interesting sort of conundrum here. One of these is wrong. This is taking error bytes, right? So we're going to run into an interesting conundrum here. What do we do when none of these match? Right? There is an error case here, right? So with that in mind, let's sort of think about this. We could go several ways, right? We could say, well, let's bake it into the Git status type. Or we could modify the results, the sort of type here, right? What I'm going to do now is I'm just going to add a case here that says unknown status, right? And what I'm going to do here is actually say this takes process output. Because in those cases, you might want to see like, what was the output then? Like, what is it that I'm not matching, right? And then once you start decorating these with more information, you also realize I actually want the file path here because I want to know uh, what was the directory. So actually, we might remove that one for now and say it takes a process output, because currently we're asking questions about directories that we already know, but we're going to see that this might actually be relevant to sort of build out a little bit, right? So with that in mind, we're going to say pure, um, like this, unknown status, and then we're going to pass the process output. And now again, we shouldn't, hang on, let's see, we have an error somewhere. Oh, of course, pure clean. This is checking for pure clean. We're gonna just say this. I'm going to just be getting all of these to line up. So now we can see we don't have process output bound anymore, and we're gonna use this trick again, or it's not really a trick, it's a feature. I'm gonna name that here. So now I have the entire process output in one variable name, but I can also destructure it at the same time. So with this in mind, what happens when we run stuff now? We were checking our current directory that reports unstaged changes, of course, because I'm actually working on it currently. /tmp is not a Git repository, right? So it has correctly identified this is not a Git repository. So with that in mind, let's say that we go into tmp, we make some directories, d123, we go into d1 and say git init. We go into d2, we say git init, touch hello, git add hello, git commit initial. And now this should be, if we run git status here, number 2 is nothing to commit working tree clean, right? So what I'm going to do is I'm going to say d3 and say git init, touch hello, git add hello. And now we're going to change hello. So we're going to have unstaged changes, right? So we're going to try this out a little bit now. So echo change into hello. So if you run git status now, we should get unstaged changes, right? So now we can try this with different directories here. We have D1, which has no commits. Let's see if that matches. It does. D2 should be clean. It is. D3 is the one with unstaged changes, right? And TMP itself is not a Git repository, right? So now we're saying we're reporting the correct thing for these, right? So with that in mind, how would we go about saying, I want the result for all of the subdirectories, right? What are the rules for this, right? Because there's a certain kind of, in a way, there's a structure here, right? If we find the Git directory, right, the entire thing below is a Git directory, right? If we don't have a Git directory, we want to sort of recursively search the children, right? So let's start making a function called get git statuses. It's going to take a file path and return many git statuses. Get git statuses path. So what we're going to need is one get status that we currently, let's call this a current get status. or local git status. That's get status with our current path that we actually are in, or rather the one that we're searching, right? So what happens now, case local git status, we're gonna inspect this to see what do we have. And now we're gonna sort of think about these rules, right? So if the git status is clean, right, we're going to just say pure clean, okay? So if we have unstaged changes, we're gonna say pure unstaged changes. If we have no commits, this one is also simple, pure no commits. If we have an unknown status, and here we have a process output, right? We can actually say unknown and say this effectively. We can say pure unknown. So here, what I've done here is I'm using this at operator again to say this whole thing is bound as unknown, right? Now, we want to recurse, right? Go deeper when we don't have a Git repository, because we know we want to report on the children of this path, right? So, with that in mind, when we don't have a Git repository, right, we want to get the subdirectories of that folder, right, and then go deeper into them, right? So subdirectories is equal to get subdirectories of that path, right? Subdirectories here, it's going to be a list of file paths. Let's say it's going to be that. I'm going to be creating these. So we're essentially in the design process of solving this problem here right now. So for each, and here we're going to actually have to consider this, right? For every subdirectory, we want to check the git statuses of those, right? So git statuses is, we're gonna fmap get git statuses over the subdirectory. We're gonna find this out later, how it sort of, oh, this doesn't make sense, and so on and so forth. So we have this is just a list of git statuses. So we're gonna return that. Opa. What is this complaining? Redundant pure. Yeah, of course. It's actually doing this. So we haven't defined get subdirectories, right? We want to define that function, get subdirectories. It takes a file path and says IO file path. So what this means is, of course, we're just getting the directories that are below the given one that we have, which means we're going to have to filter on these. So we're going to get the local files, or files rather. And here I'm going to say list directory. Actually, does this exist by default? it does not. Directory list directory. We're going to import this. Import qualified rio.directory as directory. Yeah, we're going to find this out. A fold map might actually be better there. So this takes a path, obviously. So what is files here? It's a list of file path. This is what we want, except this also includes files. So we have to ask a question about the files, in a way. I can't think, this might have to be a let, but we'll see. So we're going to use a function here called filter m, and we're going to pass the files to it. Actually, we might be able to say this. So we have to pass a function to filter m. The reason it is called filter m is because it takes a thing and returns an IO of bool. So it's like filter, except it works in a monad, right? So we're working in the IO monad here, so it has to return an IO, right? So with that in mind, we have to pass it a function that takes a file path and returns an IO of bool. And when you know, there is actually a function that does literally that, right? Does directory exist? So there we have our get subdirectories function. Let's try this out. So get subdirectories. For my current directory, it returns the subdirectories. So tmp. Oh, hang on, that's interesting. Now we have to consider, why would it not return the correct result for tmp, right? The reason for this is because if we go through this, we get the files, right? What happens when we get the files? Let's print or trace show m files. Now we're going to see them printed, right? These are the files that exist in tmp, right? But what do they not have? They don't have the correct paths, right? These are just the files as they are called locally inside of tmp. They don't have tmp before them, right? So I'm going to create a utility function here. It actually it might already exist inside of Rio. Let's see. I'm going to say let files with complete file paths equals. So we're going to map over our files and say apply a function. This function has to return a file path from a file path, right? So we are going to say for each path, take the path. So take the current path we're searching and concatenate the current path to it. Okay, so it turns out this this utility function is not available. We're going to create it. It's not a big deal. So here's how you create an operator in Haskell. So this takes a file path and another file path and returns a file path. So it's just concatenating this. And I want to sort of show this because it's a useful utility to have, actually. It's kind of good. So P1 with this operator and P2 equals the concatenation of P1 and a slash and P2. So to be clear, this could also be written P1 concatenate slash P2, right? There's a tiny detail that I want to actually show here. I want to say drop ending slash s. And we're going to create that utility as well. Drop ending slashes takes a file path and returns a new file path. Drop ending slashes itself is just a function that's going to import rio.list qualified. So list drop while end, I think it is. And we're going to say that if the character we're looking for is equal to slash, we're going to drop it. And this function here, you can see that I have, it's an anonymous function, takes a C character, checks it for this. What we can do here is actually we can reduce this to say this. This function will automatically know it's looking for one argument because it's missing one argument. So list drop while end takes a predicate and a list of things and returns a list of things, dropping from the end of that. So what we're getting here is if P1 has slashes at the end, we're not going to get those, right? So with this in mind, now we can actually use this here, right? So we can say, well, concatenate for every path, concatenate path together with P, right? And again, what we can do here is P is really not needed here because that's the file path that we had there, right? So let's show the complete file paths here. I'm going to run this function again. And now we get the actual complete stuff, right? Now, since we're looking for the correct paths and everything, we get the subpaths of things, right? So this is very useful. Let's stop showing that. And now we have our get subdirectories function, right? What happens if we run not or get statuses now on TMP? I think we have some prints here still. Oh, I haven't removed the prints, of course. Okay, so this is awkward, right? We have no commits, clean, and unstaged changes, right? But yeah, that actually matches what we want. Because if we look at D1, git status, it has no commits. If we look at D2, git status, it's clean, right? So that's this one, or rather this one. And if we look at the third one, we had unstaged changes, right? So this matches, but we just have a list of these, right? So what I'm going to do, what I talked about before, is I'm going to decorate these with our file path. So let's also, no, we don't need to decorate the git, not git repository one. And because, as you can see, I've added now these things, we get compilation errors, right? And this is good. This means that we are not going to end up in a situation where we can sort of work with these things incorrectly, right? So unstaged changes also has a path. The reason I'm underscoring these is because we already have the path that we are currently working with. This is going to be important only for how we actually choose to deal with this data, right? So no commits also takes a path. And this might be it. Let's also say unknown status current. It should also have a path. '16. There you go. And now, since we're trying to return these, now we have to return the path, right? So we have to construct these in the correct way. And no commits also takes the path that we have. And not git repository doesn't take this. So we're not going to do it for that. And there we should have something. Let's see if we can reload here and get good stuff. And there you go. Right? And this is interesting now because we have effectively kind of reached a situation where we could start doing this, properly, right? So I'm going to create some more directories here, D4, and I'm going to say inside of that, there's actually sub 1, 2, and 3. Inside of D4 sub 2, we're going to do a empty git repository. And there you go. We have effectively, essentially created a tool for going down into these and saying, yeah, what's down there, right? So now we have get statuses, right? And we've reached this point by really not running anything. Like we're just doing this in the terminal, right? Now I'm searching my entire system in the REPL. Might be an extremely bad idea. Actually, it probably is. Let's stop doing that. Let's search only the TMP folder for now. I'm going to show this actually in my normal setup, because obviously we're in a development container right now. So yeah, let's turn this into an actual thing that sort of uses environment variables and so on, right? So in run main here, we're currently just saying run hello world, right? So if I run main here, it's just going to do this, right? So what we're going to do, actually, we didn't need real byte string. That's interesting. Why didn't we need, actually, yeah, okay. Yeah, byte string is imported by default, the strict one. Okay, never mind. Rio is great. That's why. So we're going to get the arguments for the program. And this is obviously just like any other, right? I'm going to preemptively say it's environment get args here, because I happen to know it's that function, right? If I could spell it correctly, we're going to see. Yeah, import qualified. Rio environment. Environment, thank you very much, as environment. And so we're going to go down there and spell that correctly. Environment, yeah. There you go. We're going to check case arguments of, right? And this handling arguments, normally, I would actually use an actual library for doing this. There's opt parse applicative is a library that handles this beautifully. You construct a type that you then can use when parsing your arguments and so on, and you have these parsers for the arguments. Is very well structured and fairly easy to use once you kind of get the idea. So I really recommend that. However, in this particular case, we really only care about a path. So we're going to say if we get a list with one item in it that's a path, we're going to do some stuff. And if we get anything else, we're just going to say error, need a path to search. Why is this? Yeah, okay, because of reasons. So with this in mind, we're going to get the git statuses, right? So git statuses with the function get statuses. We're going to pass the path to this function. And then we are, in this case, let's make the program just print this, right? So put, we can do a trace show m actually, for now, because this is really not gonna sort of keeping the case. Rio environment. Okay, system environment. Right. So if we run main here, we can run main with args. So if I run it with no args, we're just going to get exception, need a path to search. If I run it with a dot here, we're getting this predictable result. If I run it with TMP, we get no commits and so on and so forth, right? So this is the structure we have there. What we want to do is we want to filter out unstaged changes from this, right? So unstaged, let unstaged equals, right? Filter, and we want to apply some kind of function here to get statuses. And here we want to say pure, just because we want to get this compiling. So we want a function that turns a get status into a bool, right? And this should be fairly easy, right? So we want to say status, case status of, and you can actually use a anonymous lambda or anonymous case here, a lambda case. We're going to see how to do that. So if we have unstaged changes with some path, I actually want to say that that's true. For anything else or otherwise, we want to return false. And what does this actually give us? If we do trace show m unstaged, we will have our answer. And there you go. Unstaged changes is the only thing left, right? With that in mind, let's actually let's think about this filter and consider which parts do we actually need from this, right? In a way, we're currently saying, well, we're going to filter and then we're going to return the whole thing again. But the only thing we actually care about is the path, right? The unstaged path in a way, right? So let's try to rethink this and say fold R, right? Of some function here, some function here, and then we run this on get statuses. And this takes a get status and an A0 and returns an A0, right? And this takes an A0. So this is our neutral value, what we have from the beginning. So I'm going to be creating an actual list here. So I'm going to do that. Now we can see that this takes a get status and a list of things, anything, and returns a list of anything. So we're going to use this here and say, well, for a given status, right, if it's a case status of unstaged changes with some path P, we want to return the path P and paths so far. The second argument to the foldr here is the paths we have so far, the list of things we have so far. So I'm gonna concatenate those together. So our case here is for any other case, otherwise, we want to just say, well, continue with the paths you have, right? So now, what do we get? Well, we get only the paths, right? So what I'm going to do here is I want these sorted, right? So I want to add this here, and I'm going to say list.sort. Of course, we only have one example here. This will become apparent, though, that we're sorting them later. So does it look like maybe we kind of have something working here, right? Now, we're not going to see a difference here in this result. I want to show a function called for_m underscore. So what does for_m underscore do? Let's say xy. It takes something that is wrapped in something. That sounds odd. But then it also takes that something, and in this case, we want to return some IO action. So it's going to become clear what I'm trying to do here. For our unstaged things, I want to run a function that produces an IO value from a file path, right? So the paths we have in here are just strings. So what I'm going to do is I'm going to say put strlen. What happens now? We just print our paths, right? We're doing this line by line, right? So this is effectively our program, right? And I'm going to show how this can sort of work. I'm going to actually, because we're working in a development container, right? I'm going to have to basically say everything here belongs to this user, because in the development container we're actually working with sudo, right? We are root. So we're going to have to just say everything here is mine. And that's because we're going to install this. So stack install. Yeah, we don't have any compilation errors. So unstaged on my code directory should report some paths, and it does. And so we've solved sort of the issue here of just how do we find out which directories on our computer have unstaged changes in Git repositories, right? And if we go into one of these, let's copy this one, for example. Let's do this in a new split. And you can see already it has this familiar star, right? And it is a match, right? And I can attest to all of these being matches. These are projects that for one reason or another I've not pushed, not committed changes in. But yeah, so let's sort of take a look back at what we've done and figure out sort of what we've actually done step by step, right? And also let's look at some of the language features that we've used. Some of these are non-standard, so it can be useful to say to look deeper into some of these and look at sort of what are we actually doing with these language features. Why would we want to do this instead of the other stuff, right? So one particularly odd example, at least to me, I haven't used it all that much. I honestly only learned about it in the last year or so. I don't know how old it is. This is called a multi-way if, right? And the alternative to writing this multi-way if, this one here, is that because we are effectively talking about out bytes and error bytes, right? The alternative here is actually to say case whatever of, and then stating these cases. And this is, I mean, it's not bad, but it's kind of unnecessary in a way, right? So we could effectively have, essentially, we could have the same code here. This literally compiles. It's the same thing, right? But why, right? We are really, this part here is unnecessary, this unit here, right? So actually it doesn't compile. Let's see if we can. Oh yeah, of course. I have to say again, I have to bind units here in all of these cases. That's why this is actually, so let's do that for just, I wouldn't say shits and giggles necessarily, but this is what we have to say. And I mean, this gets tedious, right? So, multi-wave, I have an if, but I really just, it's kind of in a way, it's a kind of powerful switch, in a way, like, or a cond from Lisps, right? I have a few conditions that I want to check. I already have those values elsewhere, so don't bother just putting, passing them to the case, right? So that's what this is very useful for. And then this is not a language feature per se, but this function here, creating pipelines of things that we can read from top to bottom or left to right, I think is very useful. Definitely use this. Don't be afraid that people will think that you're doing something wrong. This is objectively better. Reading left to right for English speaking things is just normal, right? Um, you could argue in some cultures, right to left makes sense, but because the alternative here is to stack these functions and sort of read them from the other way, right? And I don't think that's necessarily super useful. And here's where we actually get values out of our process that we're running, and we're passing it a process configuration that we built up, right? This is, by the way, called the builder pattern, where we take a thing and we use functions to add sort of specify things. Sort of, we're building up this structure. It is essentially a specification that we build up, right? And that's why we can use this function composition to do that, right? So typed process is the library that's doing this, by the way. I think it's very good. I think it's very useful. Um, and this is a useful thing to have. It actually is included in some module. I don't really remember. We can check Google and see this one. So system.filepath.posix and Windows. It seems like it should be included in system.filepath, but regardless, this is also a good illustration. I honestly don't know if they drop ending slashes in the standard implementation. I'm just going to go ahead and use this one, because why not? It's a very short function. And again, here we're using this composition here. It's useful to know what 4m is for. We can see here that the type is, in this concrete case, we have a list of file paths. We have a function that does something with each file path, right? And it does something monadic, an action, right? And when we use the underscore version here, we get the unit result, right? So this is effectively a for each where we're just using it for the effect, the side effect here, right? So again, it's not about sort of trying to run away from side effects. It really is about managing these side effects, right? And that we're doing fairly well in most of these cases. So anyway, I wanted to show how to solve these kinds of small problems in Haskell, and trying to sort of work with the terminal a little bit and experiment with that, and essentially at the end put things together, right? At the end, this is all about solving things in small parts, right? And trying to solve the small problem first, trying that out, seeing if there are maybe some small corner cases that need solving, and then moving up a level, solving a slightly bigger problem with the help of the thing that you had before, adding things to your types, adding things to your functions as necessary, right? Realizing, hey, we actually need a working directory for commands and so on, stuff like this. I think this can be very useful, and I hope this has been a good sort of tutorial on small problem solving in Haskell, things to look out for, patterns to sort of follow. Even if they haven't, I would appreciate comments, I guess, but I'm fine with you not doing that as well. But yeah, thanks for watching. Bye.